and trying to continue, right? And we had to use different ideas or different thoughts. And I had a couple of questions, like there was one on big ideas where there was no addition or subtraction rule that was happening. And so then a couple people were trying to figure out what the heck was going on with the number. It doesn't necessarily have to be an addition or subtraction or multiplication, division. Sometimes it could just be, what is the rule? What's happening? What's changing? And so you got to look at all different aspects of what's going on in order to be able to do it. So we have to use a little bit of logic or reasoning to get there. And that's what makes geometry probably different than a lot of math classes, right? Because Algebra 1, and you may or may not like geometry versus Algebra 1, but it is what it is. Algebra 1, here's an equation, we solve it, it's pretty straightforward, right? Sometimes geometry, there's a little gray area in there. Like, could be this, but it might be this, and there's not always just like, this is the only right answer. We saw it yesterday where we were trying to come up with a counterexample, and we had 3, 4, or more counterexamples, and maybe even a possibility of everybody in here having a different answer, but still being a correct answer, right? So that's really what makes geometry stand out as opposed to Algebra 1. Not always this is the only way to get there. So the types of reasoning that type of reasoning we're gonna talk about today. Yesterday was inductive reasoning, where we try to use some logic to get there. Deductive reasoning is where we try to use facts, definitions, properties, any type of information that we've had throughout the year to get us where we need to be, okay? And as we go throughout the year, eventually we'll get into some proofs, and we'll say, why can I do this? And then you're gonna have to tell me why it's okay to do this specific step. And you're gonna have to give me a reasoning or a proof as to why. And we did that a little bit yesterday. But yesterday was more coming up with the conjecture and then providing counterexamples. So an example of like deductive reasoning, and we've talked about this before, but I always use the example of like a crime has been committed, right? You watch like Law and Order, okay? Law and Order would be a great example of it. Anybody ever watch Law and Order on TV? There's all kinds of different ones of them, okay? And basically they go from the beginning where the crime happened all the way through the trial and if the person's innocent or guilty, right? And so it's just like a storyline, right? The crime's committed at the beginning of the show, and then in comes the detectives and the police department, and they start doing their investigation. They come to a conclusion, and they're gonna say this guy or this lady was the one that we think committed the crime. But then what do they have to do? Are they just gonna say, Ben's going on trial, right? Why is Ben gonna go on trial? Because we got some evidence saying he was the one that did it, right? So they gotta collect evidence, and they gotta have reason. They can't just say that person did it with nothing to back it up, okay? And then eventually you go through the trial, you prove why you think they did it, and then if it's a jury trial, then the jury will have to decide if that is indeed the case, if that specific person committed the crime, okay? And so that's using deductive reasoning, and an example of where you can see it being used. But we really use deductive reasoning every single day, okay? We don't necessarily say, hey, I'm using deductive reasoning here, but you do it without even knowing that you're doing it. There's two different laws that we're going to talk about today. One's called the law of detachment. If the hypothesis is true, then the conclusion must also be true. If today is Friday, then it's the last day of the school week, okay? And then you would restate it and say, guess what? Today's Friday. And then what our conclusion would be is, it's the last day of the school week, right? Or you could say something like, if today is Friday, then today is the first day of the state fair, okay? And that's not true for every Friday, but for this Friday, it is, because the fair kickstarts today. And so that would be an example of the law of detachment. If this happens, then there's the conclusion. If it is lightning outside, then we have to go inside. for practice. That happened this week, right? We had some lightning towards the end of practice, so guess where we ended up? We had to go inside, right? We can't stay outside while it's lightning out. So that would be the law of detachment. It's an example of deductive reasoning. First thing had to happen. Lightning had to happen first. Once that happened, that moved us inside. Okay, the second one is what we call the law of syllogism. Does the conclusion of one statement match the hypothesis of another? If that is true, then we're going to combine them into an if-then form. Okay, so I'm going to show you an example of the law of syllogism. Okay, first couple of examples here are using what we call the law of detachment. What statement could follow the two true statements? If two segments have the same length, then they are congruent. Okay, this is an if-then statement. If two segments have the same length, then they are congruent. Then it's going to restate that in a little bit different way, not necessarily an if-then form. They tell us BC is 6. If BC doesn't have a symbol over it, what's it mean? It's distance, right? So we're saying the distance from B to C is 6. The distance from X to Y is 6. So do BC and XY have the same length? Yeah. And so if those two segments have the same length, then what can I conclude? They are congruent, okay? And guess what? My conclusion here is really simple. All I have to do is say segment BC is congruent to segment XY. And there's, remember our congruent symbol, the tilde sign with the equal sign underneath it. You could write it out in words if you want to. You could write out BC is congruent to XY, but this is so much easier. Use the symbol, right? That's why we use the symbols, to make it a little bit easier to rewrite that statement. Okay. But if I would have told you that this was 6 and this was 7, would there be a conclusion? No, because they're not the same, right? So if they're not the same, then I can't make a statement. And so then I would just say there's no conclusion to be made. Okay, the second one, read the if-then statement first. If a measure of an angle is between 90 and 180, then that angle is obtuse. Okay, then they're going to restate the hypothesis. Okay, angle R is 155. Now it doesn't say angle R is between 90 and 180, but what do I know about 155? It's between 90 and 180, right? So I'm using my reasoning here to say, hey, wait a second, 155 is between there. So now what conclusion can I make about angle R? Angle R is obtuse. Okay? You don't have to write it as an if-then statement. You don't have to do anything specific. You're just using the info that we have to rewrite it. If I tell you that angle R is 30 degrees, can we make a conclusion? No. Now, we know 30 degrees is acute, but once again, we're only using the information that's given here, okay? I'm just going to write this one out, and you can write it out if, I know you don't have a ton of room here, but I'm going to show you an example first, and then we'll look at some of the examples that are on the notes. Okay, this one's probably the one that's the hardest out of all. If it rains today, then I will use my umbrella. If I use my umbrella, then I will stay dry. So here's what's happening. The conclusion here is matching with the hypothesis here. these two both talk about using the umbrella, right? So that's kind of the link between those two statements. So then what we're going to do is we're going to combine these two statements together to make a new if-then statement. So we're going to be given two if-then statements, and we're going to combine it to make a third. And so what we're going to do here is, this is my if statement. This is my then statement. And I won't write it out, but I would say, if it rains today, then I will stay dry. And we get rid of that middle part, that common part, because they link the two statements together. But this has to be true, this has to be true before we can combine them together. Okay? So that's an example of what we call the law of syllogism. We're taking two statements, combining them together to make a third. Okay, the ones over here are the law of syllogism. Okay, the law of syllogism, we're going to take two if-then statements, and we're going to try to combine them together if we can. Okay, so first one. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Now here's where it gets a little bit tricky, okay? The conclusion has to match up with the hypothesis. Are these two statements the same? No. Two completely different statements, right? So then you might say, oh wait, we can't do anything. But here's the other thing you got to look for. What if I read this one first? If x is greater than 5, then x squared is greater than 25. So does this conclusion match with this hypothesis? Yeah, okay? So you got to look at the sentence two different ways, okay? What if I write the second sentence first and flip it around? Now this conclusion matches this hypothesis. So what's my if statement going to say here? If what? If x is greater than 5. If x is greater than 5, then x squared is greater than 20. Okay, which would be that statement right there. Okay, let's look at part B. The one thing we always want to do here is, I always like to underline it. Does this conclusion match this hypothesis? The angles in the interior of a polygon are congruent. A polygon is irregular. Are those two statements saying the same thing? And it's got to be worded the same way. This one is talking about the interior angles being congruent. This one is just talking about being irregular. Okay? Not the same, right? So it doesn't work that way. So then we try flipping the statement around. Does this conclusion match this hypothesis? Sides are congruent, polygon is regular. Are those two statements the same thing? No. Okay. They have to state the exact same thing. All sides are congruent, all sides are congruent. Polygon is regular, polygon is regular. They have to say the exact same thing. We can't try to think outside the box here of trying to make our own statement. They have to state the exact same thing. They don't state the exact same thing, right? What two statements actually match up here? What are those two parts? What do we call those two? The polygon is regular, the polygon is regular. They both follow what word? If. What part follows the if? Well, then if we're writing a true conditional, but what do we call the part that has if in it? Hypothesis, okay? So here we have two hypotheses, okay? Hypothesis here and hypothesis here. Doesn't work, okay? Because if I tried to combine these together, the two if statements are the same, my conclusion would be then all angles in the interior polygon are congruent, then all of its sides are congruent. I have two then statements. That doesn't make sense, right? I don't have a then statement. I have an if then statement. Here the two ifs are the same. So here what we would say is there is no conclusion to be made. And that'll be the case sometimes. And I'm going to go ahead and write here that two hypothesis statements are the same. And we need it to be in a hypothesis and a conclusion. Okay. Last one. If you get an A on your math test, then you go to the movies. If you go to the movies, then you can watch your favorite actor. Okay? Does the conclusion of one match the hypothesis of another? You can go to the movies, you go to the movies. Are those two saying the same thing? Mm-hmm. Yeah, going to the movies, right? So now we're going to put this hypothesis, if you get an A on your math test, then you can watch your favorite actor. We're not saying anything about the movies because the two movie statements are what links us together. Okay? So we drop that off and we make a third new if-then statement. Okay? Questions on any of those? So really be careful of the directions today. Are they